Good afternoon, everyone. My name is Jet Hong Lo. Today, I'm going to present about resource-based test case generation for RESTful web services. Now, I'm going to give a brief introduction on what REST is. So, REST is not a protocol. Instead, it is an architectural style for providing design standards and rules on architecture, web services, and communication for building web services using the HTTP protocol. So this is a HTTP message, and this is the resource path. It indicates the target of the request, referring to a resource that will be accessed, which is the create page. This is the method and verb. It is the type of operation like get, head, post, put, and patch that it performs on specific resource. This is the headers. It carries additional information with the request or response. This is the body. It carries the payload of the message. Why is the research important? In recent years, the application of REST for building web services is growing in the industry. It is widely used and applied by many big companies such as Google, Twitter, Amazon, and etc. due to its usefulness for providing public APIs of cloud services over the internet. A lot of people are using it, but testing RESTful web services is quite challenging and difficult. In this research, they have proposed an enhanced search-based approach for automated system test generation for RESTful web services. This approach integrated with many independent objective and AWOL master. The many independent objective algorithm is specialized for system test case generation with the aim of maximizing code coverage and fault finding. So now I'm going to briefly describe what this visual code means. So the search is started with an empty population for each optimization target. Afterwards, at each step with probability PR, MIO algorithm either samples new tests at random or sample a test from a population that includes uncovered targets. Next, the sample test may be added to the population if it achieves any improvement on covered targets. Once the size of the population exceeds the population limit N, the test with worst performance is removed. In addition, at the end of the step, if an optimization target is covered, the associated population size is drawn to 1, and no more sampling is allowed from that population. Moving on to the next slide, resource and individual. An individual is a test case composed of sequence of HTTP calls. In this paper, they can only use posts to create resource. Here are the sets of templates that list meaningful combination of actions on one resource based on the semantics of HTTP methods. For example, post get, post put, post patch. They use templates to sample new individuals instead of sampling them completely at random, because it's unlikely to generate the same resource for several HTTP calls. Independent templates are when actions with template are executed, they do not have any effect on follow-up actions on any resource. A non-independent template is independence cannot be assumed. It might or might not be dependent because it varies from resources, and dependency of resources are usually unknown before a search starts. The next step is resource-based smart sampling. There are 4 methods to sample individuals. It enables us to sample tests with different consideration on resources, which shown below. S1IR is sample one resource with independent template, and the precondition is at least one independent template exists in the system under testing. S1DR sample one resource with non-independent template. The precondition is at least one non-independent resource exists in the S system under testing. S2DR is sample two resources and only allows the last resource with non-parameter get. The precondition is at least two non-independent resources exist in the system under testing. SMDR sample more than two resources and only allows the last resource with non-parameter get. The precondition is at least three non-independent resources exist in system under testing. So for the probability of all these methods added up equal to 1. Since resources involved vary from system under testing, the paper designed 5 strategies to determine which method should be applied at the beginning of each sampling. The first one is equal probability. It selects methods at random with uniform probability, so it's 1 over number of applicable methods. The second is action-based. It enables a selection method based on proportion of applicable templates. And then the third one, use budget-based. It enables an adaptive selection based on the passing of search time. So it samples an individual with one resource with high probability. Then only spend effort on multiple resources if there's still enough available budget to allow that. Then there's an archive-based. It enables an adaptive selection based on the achieved improvement of fitness. The last one, con-archive-based. It enables an adaptive selection based on fitness improvement after a certain amount of sampling actions on one resource. The third step is resource-based mutation. In this paper, resource-based mutation follows the same mechanism with many independent objectives for mutating an individual. For example, mutate the values on the parameters such as HTTP, CORS, headers, and body payloads. And mutate the structure of a test, which is adding or removing HTTP CORS in the test. After mutation, it will automatically update all previous action in the same resource. In total, there are 5 operators to mutate a structure of individual for exploiting relationship among resources and different template on resources. So there's delete a resource together with all associated actions, swap the position of 2 resources, add a set of action on a resource with another set of new resource, and then there's a modify, so there's modify the set of action in the resource. Experiment settings. Base 1 is an implementation of default many independent objectives for the REST problem, and base 2 is applying smart sampling to the many independent objective. And figure 1 is using all of these values to run MIO algorithm. Experiment table 5, we can see paper approach has the best overall result. The best average number of covered targets are obtained by the approach in 6 of 7 case studies, except REST news. Experiment results table 6. We have concluded that MIO enhanced with con-archive-based strategy with 50% probability and resource-based mutation perform significantly better, up to 42%, on system under testing that use independent resources. Dislike and like about this research paper. What I like about this research paper is that it is automated for testing. This helps the developers to improve the code coverage without spending a lot of time in it. And then what if there's another developer group that doesn't work on this, and they can easily do the automatic testing without going deeper into the code and trying to understand it. And the dislike about this research paper is that it's taking too long to run the test, and it needs to be tested 40 times to be sure we got the accurate result of code coverage.